Imagine staring up at the night sky, a vast canvas dotted with countless stars. Most are distant, tiny points of light, but some some are true monsters. Today, we're talking about one of the most extreme, S Doradus, a hypergiant star so luminous and powerful it almost defies imagination. And we're going to ask a wild question: what if you fell into it? First, let's get acquainted with this celestial beast. S Doradus, in our galaxy, it resides in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, about 160,000 light-years away. Even at that incredible distance, it's one of the brightest stars we can see. Why? Because it's a luminous blue variable, or LBV. These are massive, unstable stars nearing the end of their lives, and they are incredibly bright. S Doradus shines with the light of about 1 million suns. Yes, you heard that right, 1 million. It's also huge. If you were to place S Doradus in the center of our solar system, it would swallow Mercury, Venus, Earth, and Mars, with its outer layers reaching well into the asteroid belt. Its radius can fluctuate, but it's typically hundreds of times larger than our Sun. It's a true cosmic leviathan. So, let's start our hypothetical journey. The following part is tricky. You wouldn't just drop into it like a well. You'd need a spaceship, and it would have to be the most advanced, most indestructible craft ever conceived. Let's call it the Icarus II, but hopefully with a better outcome than the original. Our journey begins hundreds of millions of kilometers away, still far outside what we'd consider the star's surface. Even from this distance, the view would be terrifyingly beautiful. S Doradus wouldn't be a point of light, it would be a blinding, brilliant disk filling a huge portion of your view screen. The raw energy pouring off it would be immense. Your ship's cooling systems would be working overtime, battling a tidal wave of radiation. The solar wind from S Doradus in a gentle breeze. It's a hurricane of charged particles moving at millions of kilometers per hour, stripping away tons of the star's own mass every single year. Your ship would be sandblasted by a stellar storm of epic proportions. As the Icarus II pushes closer, things get more intense. The light would be so bright that even with the most advanced filters, looking directly at it would be impossible. We're talking about a level of brightness that would vaporize any standard camera sensor instantly. The predominant color would be a fierce, electric blue-white, a sign of its incredibly high surface temperature somewhere around 20,000 degrees Celsius, more than 3 times hotter than our Sun. Now, let's talk about gravity. S Doradus is somewhere between 20 to 45 times the mass of our Sun. As you get closer, the gravitational pull would become staggering. Your ship would be accelerating to incredible speeds, and you'd be experiencing crushing g-forces unless your inertial dampeners were working perfectly. But S Doradus has another trick up its sleeve. It's an unstable, variable star. This means it has violent outbursts, ejecting massive shells of its own material into space. Imagine flying through a sudden, star-sized eruption. Your ship would be engulfed in a cloud of superheated gas, a stellar nebula being born right in front of you. Navigating this would be like trying to fly a plane through a volcanic pyroclastic flow, but a million times hotter and larger. The chances of survival, even for our supership, are dwindling fast. Let's assume you survive the radiation, the stellar wind, and the outbursts. You are now approaching what we call the photosphere, the visible surface of the star. But a star like S Doradus doesn't have a solid surface. It's a roiling, chaotic ball of plasma. The surface is just the point where the gas becomes so dense that you can't see through it anymore. The moment the Icarus II touches this layer, it's game over. There is no material we know of, real or theoretical, that could withstand these conditions. The ship would be instantly torn apart and vaporized. The atoms of your ship, and you, would be ripped apart into a plasma of electrons and atomic nuclei, becoming one with the star itself. It would be an instantaneous, complete annihilation. But let's push our thought experiment to its absolute limit. What if, by some impossible magic, you could survive the plunge into the photosphere? What would you see? You wouldn't see anything. You'd be inside an opaque, blindingly bright inferno. It's not like swimming in water. It's like being inside the filament of a light bulb the size of a solar system. The pressure would be unimaginable, millions of times greater than at the bottom of Earth's deepest ocean. This pressure would crush any conceivable structure instantly. As you fall deeper, the temperature and pressure would skyrocket. You'd be sinking through layers of superheated hydrogen and helium plasma. Convection currents, larger than our entire planet, would be churning around you, carrying energy from the core to the surface. You'd be tossed around in a cosmic washing machine of unimaginable violence. Eventually, you would reach the core. Here, the conditions are truly mind-boggling. The temperature soars to tens of millions of degrees Celsius, and the pressure is so immense that it forces hydrogen atoms to fuse together to create helium. This is nuclear fusion, the engine that powers the star. At this point, you are not just a part of the star, you are fuel for its fusion reactor. The very atoms that once made up your body would be participating in the nuclear reactions that make S Doradus shine so brightly across the cosmos. In a strange, poetic way, by falling into the star, you would become a part of its light. The energy released from the fusion of your atoms would begin a long journey, taking thousands, maybe even millions of years to travel from the core to the surface. Once it escapes, it would travel across space as light, journeying for 160,000 years until it reaches another distant galaxy, perhaps our own Milky Way. And maybe, just maybe, some future astronomer on a distant planet would look up, point their telescope at the Large Magellanic Cloud, and see the faint, ancient light from S Doradus, light that you, in the most bizarre and final way, helped to create. So, what if you fell into S Doradus? It would be a journey of terrifying beauty, ending in total, instantaneous annihilation. You'd be overwhelmed by light, radiation, and heat long before you even got close. But in the grand, cosmic scheme of things, your matter would be recycled, becoming part of a stellar giant and contributing to the light that illuminates the universe. It's a humbling, and frankly, horrifying thought, but it highlights the incredible power and scale of the cosmos we live in. Stars like S Doradus aren't just pretty lights. They are unimaginably powerful engines of creation, and we are lucky to be able to observe them from a very, very safe distance. Thank you so much for joining me on this wild, cosmic journey. If you enjoyed this thought experiment, make sure to hit that like button and subscribe for more adventures into the what-ifs of our universe. Let me know in the comments what cosmic destination you'd like to explore next. Stay curious, and I'll see you in the next video.